Okay, in this video, I'd like to go through an example that uses intermediate value theorem, or IVT. And IVT is one of the first things we learned at the beginning of the year. And I'm saying that because there's not a lot of calculus that you have to have or know or establish in order to use it. Really, all you need to do is make sure you have a continuous function. And the idea behind the intermediate value theorem, just to kind of give you a graphical point of view maybe, is that as long as you have a continuous function on a closed interval. So here's A, here's B. So you just need to have a continuous function. I mean, there could be a cusp, right? We never even talked about differentiability at this time, right? You just have to be continuous. So no holes, no jumps, no asymptotes, no death by oscillation. As long as you have a continuous function, then what ends up happening is if you look at the y values, so here's where f of a is, and here's where f of b is, that as long as you have a continuous function, whatever your starting term is and whatever your ending term is in terms of a y value, that means every single thing that's in between those, every single thing that's in between those two y values will be achieved or will be hit. Will have some value in the in the given interval. There'll be some x that corresponds to it. So there, like there's going to be for this spot right here, that's f of c. So because f of c comes between f of b and f of a, that simply means that somewhere there's going to be at least one c value. Now there might be more, right? There might be one here, there might be one here, but they're always going to fall within that interval a to b. And again, the only thing you need to make sure is that you are continuous on a closed interval. Okay. So without a calculator, let's show that this graph of e to the cosine x minus 3 sine x crosses the x-axis at some point. So first of all, we just need to establish, f of x, it's continuous. It's an awkward function, but yes, it is continuous. And how do I know it's continuous? Well, because e to the x is always continuous. Sine and cosine are always continuous. You're not dividing by 0 or square rooting a negative. So I definitely know it's continuous on the interval from 0 to pi over 2. And then the next thing I want to do is analyze, well, what is f of 0? F of 0 is equal to, let's see, e to the cosine of 0 minus 3 sine of 0. Well, cosine of 0 is 1, so this gives me e, and then sine of 0 is 0, so basically I get e minus 0, which is equal to e. So f of 0 is e. Well, now what's f of pi over 2? So that's e to the cosine of pi over 2 minus 3 sine of pi over 2. Well, cosine of pi over 2 is 0, so I get e to the 0 minus, and then sine of pi over 2 is 1, so minus 3. But e to the 0 is 1, so 1 minus 3, which is equal to negative 2. So I know that f of 0 is e, so f of 0 is e, and I know that f of pi over 2 is negative 2. And we're trying to show that it crosses the x-axis. Well, when you cross the x-axis, whatever that happens at f of c, when you cross the x-axis, that's equivalent to having a y value of 0. And notice, 0 is exactly in between negative 2 and e. So since I have a continuous function, which I have already established on that closed interval, and I've shown where the initial y value is, the initial y value is e, and the final y value is negative 2. So again, like if I had this graph, I know I'm starting at 0, comma e. So there's 0, comma e, and I finish at pi over 2, negative 2, wherever that's at. Pi over 2, negative 2. Because I'm continuous, there's no choice. I have to get from point A to point B. At some point, I've got to cross the x-axis. So whatever, right, because that's where your f of 0 is. So there's f of 0. So it crosses at some point, and guess what? That's in between 0 and pi over 2. So so how do I make that conclusion? So since it's continuous and we found our endpoints, I could say thus IVT, intermediate value theorem, guarantees at least one C value in the interval, so it's an x, in the interval, 0 is less than or equal to x is less than or equal to pi over 2. Maybe I can put like c right there. There you go. So there's at least one c value in the interval such that f of c is equal to 0. And I could say since 0 is in the interval of, what was it? -2 less than or equal to a y value is less than or equal to e. Perfect. And really, when you look at the intermediate value theorem and how it's graded on the AP exam, they really need to make sure that you are stating of a continuous function and you're looking at the endpoints, the high and the low, and therefore everything in between, including the value you're after, will be achieved within that given interval.